Hello students. So in today's lesson, we are going to look at special identities. So what exactly are special identities? We can understand identities as a mathematical statement where it is always true regardless of the values of the unknown, right? So this is something that we have spoken about previously. So over here, I'd like to introduce to you three special identities that we are going to use in terms of trying to help us to perform expansion and later on for factorization. So here are the special identities. The first one, okay, for the first set, right, is called the perfect squares. What happened when we have a sum squared or a difference squared? So how does it look like? The first identity over here is this. Let me highlight it in blue for you. You can see that when we have a plus b bracket squared, that means the sum of a plus b squared, regardless of the value of a and b, we are going to get a squared plus 2ab plus b squared. Now this is always true, right? Regardless of the values of a and b. Similarly, the difference, right? When we have the difference of a and b, let me highlight it in yellow. When we expand this, we already learned how to expand this. When we expand this, it will be the same value as a squared minus 2ab plus b squared. So how does this work, right? You can see in the notes that has been, the handout that has been given to you, if we expand it using the distributive law, that's how we can obtain the value. Later on, I will show you another way to visualize it. But let's use these two identities to answer some questions that we have below, right? So first one over here, when we have 2 plus x squared, so it's a sum of 2 and x. So if you look at the blue portion, you can see that they are of the same structure. So what this means is that I know that this could be written as, okay, a squared plus 2ab plus b squared, right? So what we do is we identify what is a. So in this case, a has the value of 2. So I write it down. And b has the value of x. I'll write it down. So once we do this, okay, do a quick simplification. We will obtain 4 plus 4x plus x squared. There we go. So knowing the structure of these special identities allow us to do expansion and later on factorization of this kind of cases very quickly. So I highly recommend that you be very familiar with this, right? So the second question, this time round, is m minus 3n. So again, we can identify the structure. We know that this is going to be a squared minus 2ab plus b squared. Okay, notice that only the 2ab portion, right, that is different, right? The a squared and the b squared, they are always positive. So we will see why later. So same thing, identify the value of a and b. So in this case, a is m. So let's fill it in. And b is 3n. I'm going to fill it in, right? So once I do that, let's simplify this. M squared minus 6m n. And then 3n bracket square is 3n times 3n. So here I need to actually caution you. It is 3n times 3n resulting in 9n squared. It is a common mistake by some students in their haste to want to solve the question very quickly. They became careless here and they just write the result as 3n squared, forgetting that the 3 also needs to be squared. Okay, so this is a situation. Now let us look at the third identity that we want to look at now. So this time around, we talk about the difference of squared. So what happened is this, right? Instead of a plus b squared or a minus b squared, we have a plus b times a minus b. Okay, so let me highlight it maybe in red. Okay, you can see over here, right? So when we actually expand and distribute this, right? Distribute this using the distributive law, we will end up in this scenario, a squared minus b squared. Right? So this time round, the 2ab portion actually disappear, they cancel out, and the b squared portion becomes negative. Okay, we will see why it is so shortly. So using the structure, understanding the structure now, we can look at the third case, right? The third case now, we know that this is a 2 plus x, 2 minus x, so it's the same as 2a plus b, a minus b. So the structure is there, which means it will be something squared, a squared minus b squared, right? And then identifying the value, so a in this case is 2, b is x, that will give us 4 minus x squared. Cool, right? Okay, so how does all this identity actually works, right? So let's take a closer look. So let me zoom in a little bit so I have some space. Suppose, right, let me choose, let's start with blue. Okay, suppose we can look at this identity graphically. How does a plus b squared actually look like, right? So I can draw a square, that's why it's called perfect square, and then I'll break it out into parts like this. So let's see, if this length here is a, this length here is b, this length here is a, this length here is b. So the length is a plus b, the breadth is a plus b, right? So it's a square here. Now, a plus b bracket square, right? Let me write it down. A plus b squared is actually the area of this square. Wouldn't you agree? So instead of writing the area as the length times breadth, we could also just sum up all the different parts in the square, right? So in the top left corner, this area of this portion here is actually a squared, right? Because a by a, right? And the bottom right, it will be b squared. Top right, okay, is actually the length is a times b, so it's ab. Bottom left, a times b, ab. And that is how we get a squared plus 2ab plus b squared. Right? Amazing, huh? So in the same way, if we were to look at a minus b squared, this time round, drawing the square again, right? The length will be a and then negative b. A, negative b. So using the same idea, the area here will be a squared, the area in the bottom right. Now the area of the bottom right, why the square portion is positive? Because negative b times negative b will give us positive b squared. We have learned that previously, right? And then top right corner will be negative ab, and bottom left negative ab, right? So when we add them up together, we get a squared minus 2ab plus b squared. Nice, right? So the third scenario, we have a plus b times a minus b. How does this look like graphically? This time round, it will not be a square, it's a more rectangle, but doesn't matter. We can still see how it works. So what happened if this is a and then this is b? So the length will be a plus b, right? You can even put positive here. You want to make it clearer. And then down here the breadth is a here negative b. Why not, right? Okay, so if you look at this now, same idea. Top left is a squared. Bottom right now is negative b times positive b, give us a negative b squared, right? And then the top right corner, this will be ab. Bottom left is negative ab. So what happened? You realize that this portion over here, ab and the negative ab, they cancel out each other, right? They sort of do. They become 0, right? So we are left finally with just a squared minus b squared. There we go. Okay, so this is how graphically it looks like. So if you are watching this video on your own screen, you can take a screenshot of this to help you to visualize how it works. But eventually, I hope every student can have this internalized, so it will be part of you and your repertoire, your ability to just solve maths algebra questions using these identities. Okay, so let's with this understanding, let us quickly just finish up the rest of the examples. Okay, so let me clear the whiteboard. Okay, so now we know how it works. We can solve this very quickly. See, so again, right, recognize the structure very quickly. This will be 3x squared plus 2 3x y plus y squared. Notice I actually when I do substitution, right, we always put them in brackets. This is to minimize the error here, because it's 3x times 3x should give us 9x squared. If you forget the brackets and you write down 3x squared, that will be incorrect. So really form the good habit of having the brackets there. And then continuing, this will give us 6xy plus y squared. Okay, so the next question, this time round subtraction again. Recognize the structure. 5a squared minus 2 times 5a, 2b plus 2b squared. again, this is 25a squared minus 2 times 5, 10, 10 times 2, 20ab plus 4b squared. You notice I'm doing this quicker and quicker? Well, that's because as we get familiar with the structure, we can actually do these type of questions really quickly, right? And over here, again, the structure, we have a minus b, a plus b, so this will give us a squared minus b squared, right? So a is 3x here, b is 2y, that will give us 9x squared minus 4y squared. Okay, right. Now the final two examples we have here. What's the situation? Fractions, right? So this is just an example to show you that regardless of whether it's fractions or good old regular algebraic terms, no, simple ones, they all follow the same structure. There is no difference, right? So again, what I will do here, I will rewrite this as x over 6. Go back. X over 6 plus 2 squared, so that's clearer. I like it in this format, right? So in the right structure, now it's x over 6 squared plus 2 x over 6 times 2 plus 2 squared. Simplifying, we have x squared over 36 plus 2x over 3, right? Can write it this way, plus 4 plus 4. Nice, right? So fractions or not follow the same structure. Okay, so similarly, I like to write it in this way first, so that it's clearer. So it's x over 4 minus y over 3 square, right? And writing in the structure, this will give us x over 4 square minus 2 x over 4 y over 3 plus y over 3 square. So simplifying is x squared over 16 minus xy over 6 plus y squared over 9, right? Is that the last example for this section? Yes, it is. Okay, so I hope you had a better understanding of how we can use special identities to perform expansion. Have a nice day.